Yeah, hi everybody. My name is Mitchell Albert. Thank you, Iranius, for the lovely introduction. I'm going to be talking today about my time at de Havilland Aircraft in Canada, as well as a little bit about my time at McMaster as a whole. So just a little bit about me. When I started at McMaster Engineering in first year, I was dead set on chemical engineering, 4 years in and out, and boy, have things changed. I'm now entering my fifth year of materials engineering and management. If you count my co-op year, this would be my sixth year at McMaster. When I was in my 1MO3 course, I kind of fell in love with materials engineering and decided I wanted to get a little bit more involved. So Dr. Joey Kish was teaching my 1MO3, and I just asked him, hey, is there a way for me to get involved in the department, to try and get ahead something for the summer? And he said, oh, yeah, I got something for you right now. So we ended up doing a project on pipeline steel and hydrogen-induced cracking, which is something I knew nothing about. And a lot of people still don't know anything about it in my year. And then once that finished, I went into my second year. And about 3 weeks in, Dr. Rubel, who was teaching my 2HO4 class, put out an open call for research assistants for just kind of 5 to 10 hours a week, just a little bit of help on the side. And I went and I interviewed for it, and I'll get into a little bit into my interview style a little bit later, but him and I got along so well that I didn't even get the job he advertised for, but he came up with a new project that he wanted us to work on together. And that had to do with adhering hip implants into your body. Again, something when I started off, I knew nothing about. That went on for my second and third year and ended in a publication, as well as I got to go give a talk at an international conference in Phoenix, Arizona for the Biomaterials Symposium. And concurrently, after my summer, after second year, I was working with Dr. Zurab on a pipeline steel, not pipeline steel, an automotive steel application of high temperature oxidation, a lot of corrosion stuff. After all that was done, I coincidentally got a job in a very non-steel industry. I was working for Woodbridge Foam Corporation, and I was pouring polyurethane foam blocks out of about 11 or 12 bottles of chemicals. And we were using that for research and development purposes. They were building car seats, mattresses, basically anything soft to the touch, we were able to pour in our lab. When I got in my fourth year and I decided that I wanted to do a full 16-month long co-op, I first started with all the websites that were not Oscar Plus, and I was looking for keyword searches and was having a really hard time because in those websites, I found that you're going up against every university in Canada for the same position, a lot more competitive than things like finding jobs on Oscar Plus. But at the same time, a lot of the jobs on Oscar Plus were not advertised to materials engineering students. And I was having a bit of a hard time with those as well, trying to score that interview I was looking for. So I ended up with one of those, as well as a couple of materials engineering job interviews for the 16-month co-op. And it was there that I was able to execute on what I wanted to talk about when I do my interviews. And I found that it was almost more useful to be able to deliver on the experience that I've had, much more than just having the experience itself. So what I mean is, like, when someone comes up and asks you, what do you do at your job, rather than just say, oh, I'm in steel research, I would like to tell you about just like a quick speech about all the things that I've done. And for me, that gives me the opportunity to practice telling the story and to make it more short and concise and interesting, so that when I get to my interview, I really feel like I have a solid grasp on what I did, and I can make it interesting for the interviewer themselves. So for my de Havilland Aircraft interview, I was interviewed by a lady named Haiyan Tran. She's actually a McMaster grad. She's a senior materials and processes engineer at de Havilland Aircraft, or excuse me, it was at Bombardier at the time. This is going to get confusing. And she worked for the Dash 8 Q400 project. And what that is the Dash 8 Q400 is a regional turbopropeller aircraft that can seat about 72 to 90 people. And airlines like Porter or Air Canada Express, those kind of regional 2-hour flights, you're not going up too high, you're not going too far. Those kind of flights would love to fly the Q400 because it's more economical than a jet and can actually fly as fast as a jet if need be. They've been working to modify this aircraft throughout basically its entire history. It was designed and finalized in the 90s, and we can talk more about that later. So when I arrived, my office was at Downsview Park, which is basically, at the time when I started, was all owned by Bombardier, and they build the Q400 as well as their global private jet there. Oh, let's focus on what they do for the Q400 because that was what was interesting to me. They build the cockpit and wing completely from scratch at the Downsview Park facility. They receive the fuselage, the tail, and the engines. They assemble it all. They add all the flight components in. They take it, they get it painted in the decal of wherever it's going. They test it, they certify it, and they fly it to the customer. So the first one that they delivered in my time there went to Ethiopian Airlines. So it flew all the way from Downsview Park, stopping 5 or 6 times, all the way to wherever it was going in Ethiopia. The link at the bottom of this slide is a video showing the assembly that they do at Downsview Park. I think it's a really great video. It's only about 5 minutes long. It shows a lot of the things that I was not allowed to photograph because of NDA reasons. Now, a month into my internship, so June of 2019, the sale was finalized from Bombardier to sell this project to a private holding company that is owned by Roy Thompson's daughter. And so I would no longer work from Bombardier anymore. I now worked for a new company that was called the Havilland Aircraft of Canada. And if anybody is an aircraft buff, that is a very old name in Canadian aerospace. And everyone was thrilled to have it come back. So in terms of day-to-day stuff, what I did at de Havilland was actually started off a lot of non-materials work. I was put into the Aerostructures department and worked with a lot of mechanical and aerospace engineering students. We were all there were 8 of us in our group, and they started us on a project that wanted to convert the interior of the airplane from passengers to cargo. And in order to do so, they had to add cargo nets along the body of the airplane in order to prevent the crates from hurtling forward and throwing off the flight. So our job was to design provisions to attach these nets to the body of the airplane while modifying it as little as possible, because the more you modify the body of the airplane, the more work has to be done to prove that the airplane is flight certified. The entire design was done on CATIA V5, which is similar to Autodesk Inventor and some of the other solid modeling softwares that engineering at McMaster would have probably seen. The cool part about CATIA was that we had a database of every single aircraft component in the airplane. So you could start with the model of a bolt in the side of the wing and expand all the way out to the entire airplane, all modeled in CATIA. And working in this, as much as day to day it was not the most fun, it taught me a couple things. The first thing was that the courses that we take in materials engineering that are not actually materials engineering courses, they do matter. You never know what you're going to do when you get into the workforce. And so having experienced that, and for me it was 1CO3, allowed me to at least have a little bit of a jump on someone who would not have done so at all. But I was still a little bit behind the other engineers in my group because I was not, that's what they do in their programs. And so it taught me very quickly that I have to start asking some pretty smart questions of the engineers around me in order to not, I don't want to feel like they have to babysit me. They have jobs to do. Everybody has jobs to do. So I started developing questions that would answer more than one problem that I had, and just trying to really consolidate my time and act very professionally in the workplace. In terms of materials work, I did a few things, but this is what I want to talk about. We can talk about other things later if anybody would like. It was in-service failure analysis, and I worked for a guy named Eli Levy. He was a senior engineer at de Havilland and was the head of failure analysis. Unfortunately, he has passed away now. He loved teaching almost as much as he loved failure analysis. And so he really tried to take me under his wing and try and show me why he loved it so much. But at the same time, he expected me to know or to learn quickly things like the designation of different aluminum alloys, steel alloys, as well as basic corrosion mechanisms, identifying them under microscopes, and at the same time identifying fatigue versus static failure. So I could be able to look at, for example, on this slide, the two images on the bottom left, the top one are fatigue and the bottom one are static overload. And those are quick identifications that I have to make as a failure analyst. So what did we analyze and what did we investigate? Well, any in-service aircraft that we have anywhere in the world, if there was a mechanical failure that they didn't have an easy solution to, that part got shipped to Downsview Park and we carried out our investigation on it. So I worked on, I think I put out 10 or 11 internal memos at the end of all these different, each one containing a failure analysis investigation that was carried out. We worked on everything from main landing gear axle to skin panels to parts of the engine to parts of the aileron actuator to spars to ribs, any part of the airplane. You really saw it all. Now here is Ellie's kind of procedure for failure analysis. I just kind of want to point out a few things. I put the term photograph 1, 2, 3, 4 times on this slide. Ellie thought it was beyond important to really document every single little step that we took, because at some point somebody's going to want to know how we did it. It was always critical to determine what the part's background was from the airline itself, as well as what its proper use was. That normally came from an engineer at de Havilland, whoever was in charge of designing that part. It was always super critical to ensure that we looked at the entire part, not just the failure, to make sure that there was nothing else wrong with it that might lead to a new answer to why this part failed. And finally, when we put out our reports, it was always 1-ish pages of writing and then 10 one-page size figures. And those were where we spent all our time, in ensuring that we highlighted exactly what we were looking at. These took hours and hours, ensuring that whoever's reading this document can think in 2 seconds what we thought the failure method was. So just a couple other things about this. Our failure analysis investigations never ever followed this procedure. There was always some difference, some little curveball that led us down a different path. You know, we were going to failure analysis labs to run EDS, or we were recreating stress factors, all sorts of stuff. And it was never the same, but we always ended up putting out these lovely reports at the end. When I started at de Havilland, I was just a spectator, just kind of a fly on the wall. And then eventually I kind of got an assist on the report, and then I was doing parts of the investigation myself. And then the last one that I did was completely me. I did all the work, I put the report together, and it was just signed off by the engineers. And so I thought that was fun, that I was able to really come that far before my internship ended. Now, speaking of my internship ending, it did so extremely abruptly at the hands of COVID. So March 20th at 1:30 p.m., I had a job, and at 2 o'clock, none of the interns had jobs anymore. And that was the end of it. I never went back. They just restarted production in July, but they did not bring back any interns. They're not bringing any new interns in. And so it was kind of a conclusion to the point that aerospace industry is not for the faint of heart. A lot of the engineers that I worked with have been working there since the plane was designed in the 90s, and they've survived layoffs, and they've survived downturns, and they've survived everything, and they just continue going back. A lot of McMaster engineering graduates worked on this plane in the 90s and moving forward. But is the aerospace industry for me? That's something I have not decided yet. I'm focusing now on the fact that this is it for school for me. I've been in school since I was 6 years old, and now I'm 23, and this is going to be it. So in my time doing research, I watched my friends graduate, and I've made friends with grad students, and it taught me that grad school isn't as bad as it looks. It looks actually quite fun, as long as the project that you're working on interests you. And so if I'm able to find a project that interests me, I think that grad school is going to be the next step for me. So thank you all very much for listening. If anybody has any questions, I'd be happy to stay on and answer them for you.